In this lesson, it's our goal to choose appropriate displays for each data set and to recognize misleading graphs. We're going to start with two definitions. Please write a definition down for categorical data. Categorical data is data that consists of names, labels, or other non-numerical values. So you're comparing things compared to numbers, such as types of animals or city names. The second definition you're going to write down is numerical data, data that consists of numbers, for example, weights of animals or temperatures. I'm going to keep moving. You need to have these two definitions written down before you move on. Okay, so the first section is going to ask you to choose an appropriate data display. You're going to choose what type of graph to use based on what kind of data they give you. If you are given categorical data, you can choose between a bar graph and a circle graph. A bar graph compares values between its bars. A circle graph or pie graph is going to be comparing parts to a whole. It's going to have percentages. So really you're thinking about percentages. An example of a bar graph, I guess I should have done this up here. An example of a bar graph looks like this. It's similar to a histogram, something like that. And a circle graph is where you have percentages. So like this is 50%, choose blue, 25% choose red, 25% choose green. Okay. If they give you numerical data, you're going to be able to choose from a bunch of different options. For example, a line graph. A line graph you're going to choose if the data shows change over time. An example of a line graph looks like this, where you have the line goes up and down, shows positive and negative trends over time. A line plot shows how often something happens. A line plot is where there's a number line, so 5, 10, 15. Every time that number is given, you can put a circle or an X above it. So 2 people have 5 shoes, 1 person has 10 shoes, 3 people have 15 shoes. A scatter plot is next. It shows trends. An example of a scatter plot is the dots. There's numbers down here, numbers down here. And this shows a positive trend. If the dots are going this way, it shows a negative trend. If the dots are all over the place, it has no trend. Okay, there are more examples of numerical data here. Stem and leaf plot. Stem and leaf plot organizes data based on its digits. What's nice about a stem and leaf plot is that you get to see all of the values written down. I'm not going to draw that because we just did that a couple lessons ago. A histogram compares frequencies. with equal intervals, similar to a bar graph, but for numerical data. And box and whisker plot is last. A box and whisker plot organizes data into 4 equal groups. And you're really thinking about ranges and medians with this one. Okay, so they're going to give you data, and you have to decide if it's categorical or numerical and say which graph best describes it. Sometimes there's more than one answer. So our first example, let me read. This is just a summarization. The first problem, a student group solicited pledges for the number of miles they walked during a fundraiser. Ashley created a table listing the students who participated, their age, and the number of miles each student walked. Which displays could Ashley use to display the data? So you have to decide if it's categorical or numerical. Are we comparing names of things, or are we comparing numbers? Well, we're comparing the number of miles somebody walked, so we're comparing numbers. So now we have to decide which one of these we think would best describe that. Again, there's more than one answer. If there's a lot of students, maybe you're comparing all of middle school, maybe a histogram would be the best bet because it uses intervals. Maybe a box and whisker plot. Maybe even a scatter plot. I'm going to say histogram or box and whisker plot. Okay. You could put one, you could put both, you could put more. Just don't put anything from the categorical data on this list. The next example, you got the results of a survey that students asked to name their favorite type of movie, and the display is shown in percentages. So here we're comparing the different types of movies. We're no longer comparing numerical, we're comparing categorical data. So your two choices are bar graph and circle graph. Because the problem says that your data is listed in percentages, a circle graph is your best bet. Anytime that they have percentages, you're going to choose circle graph. Okay, the last section is going to ask you to identify misleading data displays. Anytime you're making a graph, you're going to want to make a graph that doesn't lead people to believe something. In real life, corporations, companies, whoever's making the graph tends to make graphs a certain way to make you believe something. And you have to be able to identify those misleading graphs. So here are some things to look out for. You do not have to draw these graphs. You can just list the things to look for. In this graph, this company chose to use a vertical scale break, or I should just say a scale break. Anytime that a graph has a scale break, meaning the y-axis jumps from 0 to a really large number, it's misleading. So scale break is the first thing you're going to write down. Now you're going to notice that this does not have a scale break, but the problem with this one is that you can't really tell the difference. It looks like there was no change between these dots, when in reality, this dot to this dot had a change of 500, so it is pretty large. So this is misleading because it has large increments. This bar graph doesn't have a scale break, doesn't have large increments, but the problem with this is the bars are all uneven. They have different widths. So when you first glance at this graph, February looks much larger than January, when in actuality there's probably a difference of 5 between them. Okay, and this last one some of you guys were doing with your histograms. There's no scale break, there's not large increments, the bars are all the same width. The issue lies within these intervals. The intervals are not the same. This interval has 1, 2, 3, 4, 5, has 5 numbers. This interval has 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This one has about 10 numbers, and this one back to 5. If there are not equal intervals, it's misleading. Yeah, this is the biggest bar. It's because the interval is much larger than the other two. I'm going to put unequal, not equal. Intervals that are not equal.